to do a difference of squares, the first thing you have to make sure is that you have two terms. Okay, so we have a question here. Above this question is how you could do it. So if you want to read that and it helps you, that's fine. I think it's best to just try a question. So the first thing we do is we make sure we have two terms. We look at this, we definitely have two terms. One term separated by another term. And then we have to understand what the words difference and the word squares actually mean. What does difference mean in math? It means subtraction. So you can only do difference of squares if you have a subtraction sign somewhere in the question. I have it there, I circled it in green. So you must have a subtraction of squares. So a subtraction of squares. Squares means like perfect square numbers or perfect square variables. So that means your terms that you have must be terms that you could square root. So could I square root the number 16? I could, right? The square root of 16 would equal 4. And can I square root x squared? The answer is that yes, you can. You can square root anything that's an even root. Right? So if you had x to the power of 8, you could square root it. If you had x to the power of 100, you could square root it. As long as it's an even root. Because by square rooting it, all you're doing is dividing it by 2. Normally you guys square root x squared, and you just know they cancel each other out. But what you're really doing is you're dividing the exponent by 2. Alright, we check to see if we have a difference of squares. We do. We have a subtraction symbol, and we have two terms that we can square root. Now we actually do the difference of squares. To do a difference of squares, we square root the entire thing. When you square root the entire thing, that'll give you x minus 4. I'm going to put that in brackets. When we factor, what do we always end up getting? We get two binomials, right? Remember the two sets of brackets? How we always have been doing that? It's no different for difference of squares. So you square root everything, you get x minus 4. But you need another set of brackets. Because whenever we're factoring, we're always getting two binomials. It's not going to be x minus 4, it's going to be x plus 4. So you're going to have one that's negative and one that's positive. So when you square root it, you get one that's negative, one that's positive. If you're not sure like how this possibly works out, if you took any question like this, I'm just going to slide that closer. Remember, we unmultiply. That's what factoring is. So if we remultiply these things together, let's just see what happens and why this works out. X and x would create x squared. X and negative 4 would be negative 4x. X and positive 4 would be positive 4x. And 4 negative 4 would be negative 16. When you go to write out all your terms, because these are opposite symbols but the same thing, otherwise, you always end up with two terms that cancel each other out. Negative 4x plus 4x would leaving you with x squared minus 16. Yeah?
Do you ever end up with two negatives in a
It'll always be one negative and one positive, because that's the only way these things will cancel each other out. And these can't both be negatives either.
Okay, so you wouldn't have like a negative x2 and x squared?
No. No, you have to have one positive and one negative. That's a good question. If you see how that ends up working, because they're opposite symbols, these terms eliminate and give you just a binomial. These have a fancy name. You don't need to know the name. It's called a conjugate. When you do Math 20-1, that's when you'll learn about conjugates. But just hearing the term now might not hurt, right? So when you have two things that are opposite, they're called a conjugate. A conjugate. If I could spell it, I'd spell it for you. It's like C-O-N-G-E-C-A-T-E, conjugate. I'm not a spelling bee expert, I teach now. Get off my back, shit. Jeez. It's okay. didn't get it either. Alright, number 2. Our first step is take a greatest common factor out. There isn't one. The next step is to count the number of terms. There's 2 terms here. Before you start doing difference of squares, make sure you actually have a difference of squares. Okay? So that means you have to have a subtraction sign somewhere. We do. Also means that you have to have terms that you can actually square root. I can square root y squared. I can square root 49. That is a difference of squares.
But what if you have terms you can't square?
If, say this question was like this, y squared minus 2. I can't square root 2, right? Then I couldn't factor. And I'd just be done. It'd be unfactorable. Yeah. Alright, it is a difference of squares, so we square root the whole thing. That would give me y minus 7. The square root of y squared is y. The square root of 49 is 7. Whenever I factor, I always end up getting 2 sets of brackets. What's in the other one? The same thing, but a plus symbol. That's it. Like, it's pretty much straightforward. Every once in a while, there's a couple tricks. We will do a couple of those, but that's pretty much it. Yeah. That's it. You're done. So once you turn a question into a multiplication question, you're done factoring. Okay. This is how most people do a question. So, they look at number 3. They see it's 2 terms. They know to factor 2 terms. You do difference of squares. Yeah, if you tried to factor, tried to do difference of squares, can I square root 2? No. Can I square root 18? No. So I actually can't difference of squares this. But you'll notice that I just made a mistake that most people would make on a test. They forget the first step. What's the first step always? Check for GCF. Is there a number that could come out of both of those terms? Okay. A 2 could come out of both of those. And when I divide both terms by a 2, I'm left with t squared minus 9. The GCF is the 2. Now I have a binomial that's a t squared minus 9, which is a difference of squares. So you GCF first. The GCF's up front. You check what you're left with and see if you can factor that thing. I can square root both those things. So when I square root those things, I would get t minus 3, t plus 9. But what about that GCF? That 2 I took out. Where should it go? Coordinates. Yeah. It just comes out front. It remains out here. Notice that I didn't write it twice. Right? I only took 1, 2 out. So there's only 1, 2 out front. Sometimes people feel that they need to put 2 in the t minus 3 and then 2 again in the t plus 3. You don't want to add an extra GCF in there somehow. You only took 1, 2 out. There should only be 1, 2 in your answer. That's one trick that could happen, where you have to GCF first and then factor. We have 1, 2, 3, 4, 5 questions here. I want you to try the first one. So give that one a shot. See if you can do it. In this one right here. This one's a little different because there's a number in front of this t squared, right? And not only that, but this number can't be divided out of the other one. There is no GCF here. So there's not a number that divides into 4 and 25. That means I can start my difference of squares process. But only if I actually have a difference of squares. So, do I have a subtraction symbol? Yes. Do I have every term can be square rooted? Can I square root the number 4? You can. It equals 2. Can I square root p squared? I can. It equals p. Can I square root 25? I can. It equals 5. So if you can square root everything, then you have a difference of squares and you're allowed to do that. So it becomes 2p minus 5. That's everything square rooted. That's the square root of 4, square root of p squared, square root of 25. Every time I factor, I end up with two binomials. So what should my other binomial be? 2e plus opposite symbol. Alright, we're going to try number 5. Number 5, what's the very first step always? According GCF. Always GCF first. Is there a number that I could take out of each term? I could take a 2 out of each term. That would give me 2x squared plus 4. First step, GCF. Second step is figure out which branch you need to go down on our little tree. We have 2 terms left under the brackets, so that means we need to do difference of squares. Can I square root x squared? Can I square root 4? Yeah, what's the problem, Courtney? It's a plus sign. This is an addition of squares, not a difference of squares, right? Difference means subtraction. So, that is your final answer, because you can't difference of squares when there's a plus sign. Alright, number 6. We're going to do number 6 together. The first step is always to try to take out a GCF. There's a big GCF in this one. So if I look at the numbers first, I can divide both numbers by 3. So there's a 3 in my GCF. Then I look and I notice that there's a W in each, so I could divide each by W. This first one only has 1 W, this one has 3 W's, so you take out the least amount, right? And how about X's? Is there an X in both? No, so I can't take out X. This thing is my GCF. What I'm left with after I divide out my GCF is 4x squared minus 3 divided by 3 would just be 1, and then W squared. I did my GCF. Check inside my brackets. How many terms do I have left inside the brackets? 2. That means I need to try difference of squares, but only if there really is a difference of squares there. Do I have a subtraction question? I do, that's good. Can I square root every single term that's in here? Can I square root 4? Can I square root x squared? Can I square root w squared? Then you do have a difference of squares, and you can square root it. Remember that the GCF is still going to stay out front, 3w. And then the other ones are going to turn into 2x minus w, 2x plus. That's what you get when you square root it. Alright, I want you to try number 7 on your own. Number 7 is a good test question. Okay, so give number 7 a try. See how you do. Good test question for 2 reasons. 1, you have to know what square root's actually doing to your exponent. So remember, it's just dividing your exponent by 2. So if I was to square root x to the power 4, I get x squared. If I was to square root 16, I get 4. Then I get x squared plus 4. How many people got that as their answer? That's awesome. That's all in the class. That's not the right answer. Why is it not the right answer, Brent?
You can still square root the x squared.
You have another difference of squares. So you actually have to factor this thing twice. You factored it once, and then you ended up with another difference of squares. So the first set of brackets could be factored again. So we're going to have to square root just the first set again. Why can't I do the second set? Because it's a plus symbol, not a minus symbol. Yeah? Good question. So when I change this one, I'm going to get x minus 2x plus 2. her question is, what do you do with this x squared plus 4? It just follows itself down. Just like a GCF would normally just be following, it just follows along. You don't need to write it out twice or anything like that. It just stays on the outside. That is the right answer. The reason that's such a good test question is it's really understanding what you're doing. You're unmultiplying. That thing actually unmultiplies to become 3 binomials. It's rare, but it happens. Number 8, also a good test question. The very first type of factoring we always want to do is GCF. And we can definitely GCF this thing. So if we look at our numbers, we have 8 and 72. Both of those numbers can be divided by 8. Awesome. That leaves me with negative x squared y squared plus 9z squared. The reason this is a good test question is it's really testing if you understand addition, and that addition can be written in any order. Because this doesn't look like a normal question to us, does it? We're used to seeing the subtraction in the middle. Look at every other question we did. Subtraction in the middle, subtraction in the middle, subtraction in the middle. So you could rewrite this thing to be 8 and then 9z squared minus x squared y squared. You can reorder addition and subtraction and it's still the same thing. Remember our example that we used a long time ago was if I took the numbers -2 plus 5 and I just reordered them to be 5 minus 2. They both equal the same thing. Even though I've reordered them, right? I took the negative as the first thing and I turned it into the second. Still the same thing, just in different order. I highly recommend, if you're doing difference of squares, you reorder it. Otherwise, people get really screwed up on what should be negative and what should be positive. So I highly recommend you reorder it to something we're used to, and then you square root it. So this would turn into 8 out front, and then 3z minus xy, 3z plus x. Yeah, bro.
So the square root it like applies.
It applies to every single thing. The 9, the z, the x, and the y. All of
So
them.
when you square root the 9, they can put the z, but then square root the z and x, y squared term, 2 terms.
It's still 2 terms because it's still separated by this negative sign. And then the second time it was separated by a positive.
Okay.
Alright, this slide right here, that's our tree that we were talking about. It doesn't have the middle part broken into 2. If you want to break in 2, feel more than free to. Yeah, you may. Before you go, I want to show you one more example. We're going to add an example to this slide. An example of difference of squares that most people don't recognize is that 1 is a number that can be square rooted. What's the square root of 1? It's just 1. So you can difference of squares that thing. Be x minus 1, x plus 1. And I know there's examples like that in your assignment or in your practice booklet. So I just wanted to make sure we understand you can square root the number 1. It's just equal to 1.